averaged.
So realistically, it is changing over time, but we can't see it.
If what you're talking about is the intensity of the electric, the amplitude of the electric field, then yeah, it goes through complete cycle oscillation. But then the magnetic field is, right, light is an electromagnetic wave.
I didn't understand this last semester, and I still don't.
So the thing to take away from this is that if it's in phase, constructive interference. If it's completely out of phase, destructive interference.
Yeah.
That's all the magic in this. Yay enough?
I guess.
Okay. So let's
$2 con gusto. This is fun.
let's see if we can make some sense of what's going on here, and try and put this at least a little bit more mathematically. So one thing that I need a little bit of suspension of disbelief. So this distance between slits I'm going to call D. I'm going to put the viewing screen a distance L away, and I want L to be much, much greater than D. Is that sort of all right? So let's see what we can do with this. So I'm going to sketch. Uh-oh. That's not good. Well, again, thought that counts, yeah? 2 straight lines. I want to let, let's see, what do I want to use for this? Wow, it gets worse and worse. I want to call that angle theta. Yeah? What is this angle and this angle?
Same.
They're both theta. Why?
It's parallel. That horizontal to start parallel.
So I am thrilled to hear you guys say that. What I will ask you guys the question that everyone always asks me.
Oh.
Well, I thought parallel lines don't intersect.
What? That's because not phi lab.
So have I ever told you guys about my do you know the story of Sisyphus?
He's the one with the wings, right?
So Sisyphus is the one who angers the gods and is condemned to spend eternity pushing a boulder uphill.
Oh, the boulder guy.
Yeah?
Okay, yeah. Yeah.
I have been tasked with a similar suffering. It is Community Art 1. I have been pushing that boulder uphill for nearly a decade and a half. And I'm still in Community Art 1. And you know what the only prereq for Community Art 2 is? Signing up for it. But it means a lot to me that someday the Community Art 1 teacher, her name's Sarah, she's a nice lady. Sarah, if you ever see this, someday I would just like you to say, Mark, I think you're ready for Community Art 2. The first time I took Community Art 1, the end of the class, she went around, like the end of the 6-week course, 8 weeks. She went around to all the people there, sweet persons, and she said, you did great, I hope you're gonna take Community Art 2. She got to me and she said, Mark, I really appreciate how hard you tried. But she gives the same assignments every semester, or it's not semester, it's
Every week.
no, it's like a 6 or 7 week course depending on whether you take it in the spring or fall or summer. But one of the assignments she gives is to go downtown and look down this very straight road and draw the buildings on the side of the road.
Oh,
And
yeah.
so-
I had to do this in music class.
I've had to do this many times. So
Me either. I didn't find any straight. Always have.
So if you do this, right, you'd see why I have been stuck in Community Art 1 forever.
Sorry, theater production.
I hate drawing.
I never
But
I think math in this university is the easiest
I don't know about the
subject.
perspective.
it's something in this family, right? It shouldn't look like this. This is why you get stuck in Community Art 1 for years and years and years. It's why all of your dog worksheets are always done in MS Paint. Because I can't draw.
That's what I say. Sometimes I even say roads like intersect with each other.
By the way, if you want to draw like this, take Sarah's Community Art 1. Now I have to send her the link. She'll really appreciate that. It's a great advertisement for it. I call this buildings down the street. But note that what you see is, even though the street is ostensibly parallel, right, at least first order, as you look off into the distance, it looks like they're approaching each other. And what I'm going to argue is that these angles are all effectively the same if L is way, way bigger than D. Is that all right? Okay. So that makes our life much easier because Sarah has to be incredibly stubborn, right? Otherwise she'd pass me on and make me someone else's problem. But I'm stubborn too. If that is D and we have two parallel rays, R1, R2, then note that after this point, right, they're all traveling, ray 1 and ray 2 are both traveling the same distance. Yeah? Well, this angle is also theta. And so given that, then this is our R2 minus R1. What's it equal to?
T sine theta.
which is just equal to d sine theta. Excellent. And so, if we want constructive interference, then what we're going to insist on is that d sine theta is equal to what? N times lambda, yeah?
Wait, why isn't it d tan
Oh,
theta?
there's the triangle there, it's a right angle there, it's the hypotenuse divided by
Oh, that's the right
opposite
angle.
over hypotenuse.
Yay?
Yeah.
If I want destructive interference, so in here we can let, so here, let's do it this way. Let's call this. So m is allowed to be 0, plus or minus 1, plus or minus 2. If I want destructive interference, then we want our d sine theta to look like what?
Would it be the same, but just add
0 to
plus
4
on that
times.
times lambda?
Yep. So we're happy-ish.
Is there a reason why we use n over there and n here?
Because I didn't look at my notes when I was writing that.
Okay.
I think that pedagogically, the reason not to use n is that I had just used it on that prior board for index of refraction.
Okay.
And so just use another thing to stand for an integer. For small angles, I think we've talked about this quite recently. So theta much, much less than 1 radian. Sine theta is approximately equal to
Theta.
cos theta is approximately equal to
X.
1. So then tan theta is approximately equal to
Tan theta sine over cosine theta.
Theta as well.
correct. Yay?
Yeah.
So if I wanted to write y in terms of things that are given, what could I say? Tan theta is equal to,
Theta equals
Zero.
theta.
So
tan theta is y over L?
Oh.
Better? Or that y is equal to L tan theta? No one gets too angry with me if I say that that is at least approximately equal to L sine theta. Yay? And so I can say that
Only because the theta is very, very small, so we can say this, right?
yeah, so this is going to start to fail as an approximation as we go very, very, very far
Oh, okay.
off of center.
Oh,
But at least for, the first, several bright and dark spots, this is going to work fairly reliably.
like shooting the laser beam to the moon. The
So
theta-
there we have to start to worry a little.
Okay.
But you also better use a really, really bright laser. And don't shine it at me. Yay? So I can replace our sine theta with our y over L, right? Yay? So if I come back to these equations and replace sine theta with y over L, so sine theta is y over L roughly, then I get d times y over L is equal to m lambda for bright spots. And so y for a bright spot is going to wind up being lambda times L over d times m. Just shuffling stuff around. Better? And so that gives us at least kind of an approximate expectation of where the bright and dark spots should be. So far, so good. So, do I want to? Okay. So let's try a quick example of this. And then let's decide if after that we have time to, so right now, I'm just telling you max, min, max, right? Alternating. If you actually carry this experiment out, what you find is that the one in the middle is bright, and the other maxes start to dim as you go off axis. There is nothing in what we've just done that explains that. But was that last Wednesday? Was it Monday? Oh, it must have been Monday. We were talking about diffraction, and there is actually an interference effect that also occurs due to diffraction. I think I told you, and again, I look goofy doing this in front of the camera, but I look goofy without the camera too. Just that there's no permanent record of it. If you look at a light source, thumb and finger near one another right before they touch, or maybe right even as you start to sense that they're touching, you see this weird fringing shadow of light and dark lines. Anyone ever see that?
I just saw it.
So they have to be really close together. If I can still see light between your thumb and finger, it's probably not. Miguel, you vouch for me? Thank you. I'm not crazy. Well, this is not evidence that I'm crazy.
Recorded.
So that is a single slit, right? But you're still seeing interference. You're seeing light and dark, right? And so the part that I haven't layered into this is that there is also interference that is coming from light passing through each of these slits, right? And so if I layer that onto this, then I can explain, and this is something that we'll do, I think, probably on Monday, why it goes brightest in the middle and starts to lessen as you go outwards. So for now, we're in kind of this ideal double slit approximation where I don't have to worry about any kind of single slit diffraction. Yay? So So then if let's space these slits .5 millimeters apart. Let's place the viewing screen let's make my life easy. 1 meter away. Let's use 500 nanometer instant light. I'd like to know where is our first minimum, and then where is the m equals 2 maximum? So there is a fair bit of plug and chug in this, right? So how do I approach this?
That would first be Y bright.
So I am trying, so let's
First it needs to be dark.
heaven help us, we're gonna regret me trying to draw this, but since this is still our ideal case, right? These should all be the same amplitude. Oh, good golly. I think I'm ready for community art too. I mean, just saying.
That's not what Sarah is.
No, it's not. But she's very polite. She would tell me that she appreciates my effort. Okay, so I want to find first min. So where is first min? And let's just stick to the so
Value.
yeah, I mean the first mins are these guys, right? So I call that y min minus 1, I suppose. But what about the m equals 2 maximum? Where is that?
The first one already mentioned.
Top of the wave.
So I have very arbitrarily changed my subscripting as I've gone along, but yay. So how do we how do we find those locations?
We use the formulas you gave us, the
Yeah.
last ones.
Yep. So lambda L over D times M is going to wind up being 500. Nano means what?
-6, -9.
Negative 9, negative 9.
Microspeeds.
Milli means
-3.
correct.
It's 0.5, is it?
Oh, thank you.
What's M?
What is M?
1.
1 or 2?
2. So approximately, what is that? So 2 over half is 4. So 4,000. Oh, good golly, someone with a calculator bail me out. Thousand. 10 to the minus 3, I'm going to say 2 millimeters.
2 millimeters, yes.
Yeah, you can do it by your hand.
Sarah, that's got to be worth something.
That's okay.
She doesn't even give grades. I mean, that's like it really is. Although I also take ceramics, and the ceramics teacher is more blunt. Like, I made a teapot, and I was so proud of this. I mean, it took me forever. And she, is this someone's pen? Like, it came out of the kiln, I was like overjoyed. She said, that lid is ginormous, and that handle's gonna snap the first time you put any water in that pot. And I was crestfallen, and she wasn't wrong. I mean, the lid was ginormous, and it, the handle wasn't on well enough that it could hold any water, but still, hurt my feelings. I paid good money for that abuse. So,
Like, call yourself a physicist.
all right. What about the location of the first minimum?
You use the white part.
What's that? Yeah.
You can do the same thing, but it's 1 plus 1.
So what do I write here?
500 times 10 to the negative 9 meters times 1 meter divided by 0.5 times 10 to the negative 3.
Oh, good golly, you're faster than I am.
1 plus 1 half.
Times
1 plus 1 half.
2/3. 1.5
Zero.
millimeters.
0 plus half.
Oh, it's the main.
Because it's the very first minimum. So let's see, if I divide this by 4, I think it's half a millimeter. Is that right?
1.5 millimeters.
Which is also the slit width. Hey. That doesn't always happen. And they all live happily ever after? For now.
How do we know it's 0?
Maybe they never see it coming.
I thought so then.
Uh-oh.
So how do we count it? It's 0 or 1 or 2 or what number?
The first,
Well, did you agree with this one? Because if you agree with this one, the difference between 2 and half is factor of 4, right?
we're saying, like, M is, I don't know how to,
I named these with an intent. This one I specifically told you was m equals 2 max, but this one I just told you was the first min. And so the first min is going to occur when our m is 0.
So would M be another number besides 0? You said the second min would be.
If I asked for the second min, that's this one, that would be m equals 1. And so then it would be 1 plus half. And that would be 3/4 of this is 1/2.
And if you go down and won't change it to negative, it just be 1.
Oh, so
Yeah, so it's symmetric. So if I wanted to go in the other direction, the first min below this central axis would be at minus half a millimeter, and the m equals 2 or minus 2. So that guy would be at a minus 2 millimeters.
So it does change to negative.
Oh, so you
Yeah, so we're going to treat this as y equals 0. Y equals 0 is exactly bisecting this thing.
Oh, okay. So you like, if you say first min, so you define it's 0. Okay. Oh, you mean that?
So if this is our y-axis, so above this central axis, y is positive, below the central axis, y is negative. Yay?
So does the max 2 ever changes, does it change accordingly as well? Or does it stay 2?
Wait, say this one more time?
For the max, does the M stay 2? Does that
Well, if I
change?
wanted
But I feel like y is 0 is
the
max.
next one, right? Oh, that's, now I'm all self-conscious about my artwork.
Sarah's not here to check.
No, that's true. This would be m equals 3.
Oh,
This
okay.
is m equals 1, this is m equals 0.
So the max.
So for maxes, I could have been smart and done this in a different color. But for the maxes, this is m equals 1, m equals 0, m equals minus 1, m equals 2, m equals 3. Yay?
Yes.
For the mins, now I'm slightly unhappy. I am slightly unhappy.
I don't think we have a 0 for the first min, do we?
I think you're right.
I think it starts with 1.
Let me double check this, but I am slightly, but then is it plus and minus? But then then is it still symmetric? Do I need to?
Good thing I asked.
learn different than you. Maybe like something related to all.
Let me think about this more, because
related to-
then then my worry becomes, this distance needs to be the same as this distance, because it is symmetric,
Yeah.
but is my equation symmetric? And I'm not 100% sure that that winds up being symmetric. Do I need to make it m minus half?
Yeah, I think so.
Let me, so I'm out of time,
no.
so I will fumble with this more.
Technically,
You're not out
you
of
can
time.
stay
I
as
don't-
drunk.
As always, guys are awesome. Have wonderful days. Thanks for stopping by. Don't be strangers. Enjoy your days. Not so much else. See you next time. I will sort out why I think I'm wrong, but I also think I'm right. I don't, I'm bothered by this.